Alrighty, here we go. This was scenario one. Everybody, take a look. So, I just sketched this up here on the little sheets I was showing you in the video. Now, the first scenario, remember, it was sitting still, not moving. And so, this is what the motion map would look like. Sitting still, meaning we have dots and no arrows, right? And then no acceleration. It's not even moving. So we can't very well have acceleration if it isn't even moving. Now, the force diagram. Several people had contacted me about being confused about force diagram. Now remember, there's two kinds of forces. We only have two kinds of forces. We have contact forces and we have field forces. All right? Contact forces and field forces. If there's a contact force, that means something is actually touching the car. All right, that'd be a contact force. And we have field forces, which can be felt even at a distance. There doesn't have to be contact for this force to exist. Now, what's acting on the car? Well, I'm going to say the gravity force from Earth. The Earth's gravity force is acting on the car, for sure, in the downward direction. And again, so the dot is my car, who I didn't circle. I didn't circle my system. Oh boy. By circling the system, I'm saying, hey, the car is the thing I'm looking at. The dot in my force diagram is the car. That's my system. All right? I wish this thing would stay focused better. It just doesn't seem to be focusing very well. If I, no. Anyway, well, it's going to have to be. Just going to have to be. Sorry it's so shaky. Man. Maybe I should have another cup of coffee or something. All right. So, we have force of gravity on car. It's acting downward. We have force of truck. That's track because I can't read. Force of track on car is pushing up on the car. Because, again, the car and the track are in contact. That'd be a contact force. Is there anything else in our diagram, in the scenario you saw, in that video, that was either making contact with the car or was acting on the car from a distance? I would say no. That's all we have. Now, I already wrote the word balanced here, and notice I put congruent marks. I put those on there because I'm trying to say that I think that the gravity is pulling down with exactly the same amount of force as what the track is pushing up. Or I could say the track is pushing up with exactly the same amount of force as what gravity is pulling down. Because the car isn't being thrown upward and the car is not falling through the table. So those forces, I would say, are equal amounts, opposite in direction. And I would say that means things are balanced. All right, have we got that? That's how I would view this scenario, scenario one. All right, now scenario two. Here we go. So there's scenario two. Now notice, the car was moving with a constant velocity. Constant velocity. I tried to show that here a little bit, I guess, in the picture. Now, how do we draw a motion map with constant velocity? Well, we have arrows that are all the same length. And notice it was moving to the right in the picture and in the video. And so that's how I have my motion map showing. And I have A is 0. Again, some of you have not been putting your A on motion maps. Make sure you do that. The A is 0. No acceleration for that car moving with a constant velocity. Now, in terms of the force diagram, is the force of gravity still acting on the car? Yes. Gravity doesn't just stop. Is the track still pushing upward on the car? I would say yes. Otherwise, the car would be falling to the floor, and it wasn't. So the track is still pushing up on the car. The gravity force is still acting downward on the car. A lot of people in this diagram, though, will put something out this way, pointing to the right, because it's moving to the right. You have motion to the right. You have a motion map that's indicating we have motion to the right. And people tend to put a force over here, and they might call it force of motion, or force of movement, or force of push. But I'm going to ask you this question. did you see, while the car was rolling across the track with a constant velocity, did you see anything touch the car besides the track? The answer to that question is no. If you did not see anything touch it, if nothing was touching the car while it was rolling with a constant velocity, then you can't make up a force here that didn't actually exist. Okay? Now, did I push the car? Of course I pushed the car. But was I pushing the car when it was traveling with a constant velocity? No. Where's the camera on this thing? No, I did not. Now, let's see. Those were my feet. Oh, a pair of scissors. Okay, where was I? I don't even know. So, the tendency to want to put a force in here is a problem. If you have trouble finding a name for it, and again, that's why we use agent object. The track, it is a physical object, okay, that is pushing on the cart or the car. Gravity is a force from the earth on the car. So it's coming from the earth. There is a physical object that is creating this force. A physical object is creating this force. So if you're having a hard time naming this for an actual object, or I should say to have an actual agent in the name, then it probably doesn't exist. Motion is not a physical object. It's not an object. It's not a thing. Push is also not an object. Now, it is something that can happen, and it is something that can be done. Things can be pushed, and things can push, but push is not an object. You have to name the force with the name of the actual physical object that was doing the pushing or pulling. Okay? And you did not see one. There was not one there while this was happening. Okay? Now, I will agree. Oh, the sun is making shadows. Oh, jeez. I will agree that there was a force acting on the car. I pushed the car before it ever came into the view on the screen. But this wasn't happening then. Okay? The constant velocity didn't start happening until after I was already done pushing and that force was gone. So this force diagram looks exactly like this force diagram, even though in this one the car is not moving, and in this one the car is moving with a constant velocity. That for some folks that is very confusing, but that's the way it is. All right, next.